Hello and good afternoon, CSI257 Section 847 students. For the first 8-week term of the spring 2015 semester, the Scaling Networks course at Anne Arundel Community College. This video tutorial is going to cover PacketTracer Activity 2.3.1.5, where we're going to talk about the configuration of per VLAN spanning tree plus. So let's go ahead and take a look at the requirements here. We're going to configure VLANs and trunks. We're going to examine and configure the spanning tree protocol, primary and secondary root bridges. We're also going to optimize the switch topology using PVST, PortFast, and Bridge Protocol Data Unit Guard. So let's jump right in here. Configure the VLANs. So we're going to enable the ports, user ports, on switch 1, switch 2, and switch 3 in access mode. And so if we take a look up here, you can see that switch 1 FA06 is VLAN 30, FA018 is VLAN 20, and FA011 is VLAN 10. So let's go ahead and pull up the first of 3 switches, switch 1, and let's increase the size of the screen here, and the CLI. And so we're going to go from user exec mode into privilege exec by issuing the enable command, and then we're going to go into global config mode with configure terminal. Once we're in global config mode, we're going to need to go into switch 1's FA06, and it's asking us to refer to the topology diagram to determine which switch ports are activated for end-user devices. These 3 ports will be configured for access mode and enabled with the no shutdown command. So I'm going to say no shut, and it looks like if I do a do show run and we take a look at FA06, right now FA06 on switch 1 is set up to be a trunk port. So we want to say switch port mode access. And we also want to put it into a certain VLAN, but let's do a show VLAN brief and let's check to see, are any VLANs currently configured? So as you can see, we don't have any VLANs configured, and specifically FA06, which is on switch 1, is currently in the default VLAN, which is VLAN 1. So let's go ahead and say switch port access VLAN, and on switch 1 it should be VLAN 30. And so it's actually going to create the VLAN for us, and that's fantastic. So now let's go ahead, and it's asking us in step 2, it says create VLANs. So it's asking us to use the appropriate command, create the VLANs 10, 20, 30, 40, 50, 60, 70, 80, and 99 on all of the switches. And thank goodness it is not going to ask us to name the VLANs. So I'll exit up one level, I'm going to say VLAN, and if I do a question mark, you can see it gives us the range is from 1 to 1005. So I'm going to say 10, 20, 30, 40, 50, 60, 70, 80, and is it 99, in the hopes that that command was going to work. And it doesn't look like that command is going to work, so we may have to go VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. Alright, so now when I do a do show VLAN brief, you can see that we've actually got our VLANs created, 10, 20, 30, 40, 50, 60, 70, 80, and 99. And VLAN 30, or I should say port FA06, is an access port, and that is in VLAN 30. So let's go ahead and knock these tasks out on switch 2 and switch 3. So we'll make switch 2 a little larger than switch 2 is currently set to be. And again, we're going to go from user exec mode into privilege exec, and then from privilege exec with the configure terminal command into global config mode. And so I'll create the VLANs first here. So we'll say VLAN 10, VLAN 20, VLAN 30, VLAN 40, and definitely getting some good practice with the VLAN command in this lab, as well as probably the RPVST plus lab, and then VLAN 99. So if I do a do show VLAN brief, you can see that we have all of our VLANs that are right there. So I'm going to exit out and we're going to go into interface on switch 2. If you look here, you can see that we're looking for interface FA018. So interface FA0/18. Let's do a do show run and see how that interface is currently configured. So as you can see, it's currently configured, but it's configured as a trunk and it's shut down. So let's go ahead and say interface, oh, I'm sorry, we're already in the interface. So we'll say switch port, mode access, and then switch port, access VLAN, and for switch 2 it's going to be VLAN 20. And then we're going to say no shut. And so this will bring the interface up, and you can see we've got green lights on both of the ports. So we did the host configuration portion, and we also created the VLAN. So let's go ahead and do the same thing on switch 3. So let's pull this over here. All right, so on switch 3, the same thing applies. We're going to go from user exec mode, we're going to issue the enable command and go to privilege exec, and from privilege exec we're going to enter the configure terminal command and go to global config. And let's go ahead and take care of the VLAN creation. VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. And it's possible that I may have had the syntax with the commas wrong. Let me try this. So we'll say 100, comma, let me see if I put some spaces in there, if that was the problem. 300, 400. No, it still does not like that. So, all right. So we're going to go one at a time. And now let's exit out here. The VLANs have been created. Do show VLAN brief. And there are our VLANs. Now let's take a look at interface FA011. So do show run. Let's see what 11 is. Also a trunk and shut down. So we're going to say switch port mode access to make it an access port. And then we're going to say switch port access to which VLAN, and switch 3, it's going to be VLAN 10. So we've got that taken care of, and now let's say no shut to bring the link up between switch 3 and PC 1. All right, so we've got that taken care of on all 3 switches, and the next is going to be to assign VLANs to the switch ports. So it says port assignments are listed in the table at the beginning of the activity. And we've actually taken care of that. So we've actually already added the VLAN assignments here, switch port assignment specifications. We've just completed that as part of our first task. So now let's go ahead and go to step 4. It says verify the VLANs. Use the show VLAN brief command. And we did that. It says assign the trunks to native VLAN 99. And so let's go ahead and do show interface trunk, and let's see, it doesn't appear that we have any trunk links that show up right now, although we do have multiple links between the switches. Let's see. Oh, configure. Okay, so step 5, we're going to be configuring each switch port FA01 to 04 on each switch as trunk ports, and we're going to assign those. It says assign these trunk ports to native VLAN 99. So let's go ahead and do that. So we'll say interface range FA0/1 to 4. We're going to say switch port mode trunk. And as you can see, it's going to change them to trunk links. And then we're going to say switch port trunk native VLAN 99. Now what we should see begin to happen here, and we'll force the issue between switches 3 and 1, is I'm going to activate switch 1's ports as trunk ports. However, I'm not going to put the native VLAN statement on there just yet. That way we can see a very common error that you'll run into. And in fact, we've got an inconsistent received a BPDU. It says blocking fast Ethernet 01 on VLAN 01. So inconsistent local VLAN. So let's go ahead and say interface FA01 to 4. And it didn't like that out of the VLAN setup. So let's try it again. And it doesn't like it there. So interface, oh, range, I apologize. FA01 to 4. So there we go. So what we're going to say is no shut. I believe the ports are probably already up. So we'll say switch port mode trunk. And you can see the state of each of those interfaces went down and is now going to come back up. And so the error that I really want you to see here is, remember, what we've already done is we've configured the trunk ports here on switch 3 to have the native VLAN 99. And that is a terrible 9. So 99. Whereas here we have no native VLAN. And so typically what happens is you'll see an error message that will come up and tell you that you've got a mismatched native VLAN. So if I were to do and in fact, let's see if, and there we go, okay. So it took a little longer than I had anticipated, but we're now getting a CDP error message, native VLAN mismatch. And obviously it's mismatched, and it's a very descriptive error message. It says discovered on Ethernet or fast Ethernet 01, and our native VLAN on our switch is 1. And it says with switch 3, who's using native VLAN 99, right? So a very descriptive message, one that you will actually probably run into at some point in your network career. So make sure that you're on the lookout for that. If there's a native VLAN mismatch, that's the error that you'll see. So to fix it, we would come over and say switch port trunk native VLAN 99. And this is also going to unblock the inconsistency that we had with spanning tree, because now we've got matching native VLANs on both sides of the trunk link. So if I were to do a do show interface trunk, you can see that the encapsulation is 802.1q and that we're trunking on all of those ports and the native VLAN is the same, right? And one of the most important fields is the VLANs in spanning tree forwarding state and not pruned, is to make sure that your VLANs, right, on the trunk ports that you have, that all of your VLANs are in the forwarding state. Because if they're not here, and let's say for VLAN 30, which is on switch 1 to PC3, if you didn't have that VLAN in a forwarding state, you might run into issues. And so now we're seeing a native VLAN mismatch on fast Ethernet 03. And again, this is actually good. CDP is catching that switch 2 also has a mismatched native VLAN. Because again, we haven't configured switch 2 yet. On switch 3, we're seeing those same error messages. So let's go ahead and take a look at switch 2 here. So we're going to say interface range FA01 to 4. We're going to say switch port mode trunk, and you can see the interfaces went down and then back up, and then we're going to say switch port trunk native VLAN 99. And that's also going to remove the inconsistency on all 4 of the switch ports on switch 2. So if I say do show interface trunk to take a look here, you can see right now we've got 3 blocking links here, right? Which is why on ports FA02, 3, and 4, none. You'll notice it says none. No traffic is being forwarded out those interfaces. We've got trunking configured on all of them. However, spanning tree is not forwarding. So if I do a do show span, you can see that ports 2, well, we've got 4 and 3 are in the learning state, so spanning tree is going to be converging here, so it'll be interesting to see what ends up happening. And we're going to look at this output a little more in detail here in a second. So we've configured the management interfaces on all three switches. I probably should have looked at that first. So let's say interface VLAN, and let me roll up here. It's going to be VLAN 99, and we're going to say IP address, and we are on switch 2, 172.31.99.2. It's a /24, so 255.255.255.0, and that interface is up. And so we've configured the management interface on switch 2. Let's do the same for switch 3. Interface VLAN 99, and IP address will be, for switch 3, 172.31.99.3. And this is a /24 as well. And then finally, let's configure the management interface on switch 1. Interface VLAN 99. So again, we're creating an SVI, a switched virtual interface, right? So it's a logical layer 3 interface, right, that's done in software on the switch. This is this is the alternative to a physically configured interface on a multi-layer switch or on a router. So this is a software switch virtual interface. So we've got VLAN 99. IP address is going to be 172.31.99.1, and also a /24. So we've got that configured. Okay, so we've got our management VLANs configured on all of our switches, and it says assign the trunks. Verify the switches are correctly configured by pinging between them. So do ping 172.31.99.2, and let's see what happens. All right, so it had to ARP out, and we've got responses from 99.2. Now let's check 99.3. And so remember that I'm on, right now we're on switch 1. So let's say do trace 172.31.99.2. So switch 1 goes directly to switch 2 to get to that address. And what about .3? We go directly to switch 3, right? So that looks good there. And if I can ping from switch 1 to 2 and 3, I can also ping in the opposite direction. So that concludes step 5. All right, now into the heart of the per VLAN spanning tree plus and some load balancing. It says because there's a separate instance of spanning tree for every active VLAN, a separate root election is conducted for each instance. And so who is our root bridge right now? And let's talk about that root bridge election and how that takes place. So the first criteria for the root bridge election is going to be the priority. What is the priority set to on the switch? And the priority values range from 0 to 61,440. And let me confirm that it is 61,440 here real quick. And we'll say spanning tree VLAN 10, priority 61,440, right? So there you go. So it's from 0 to 61,440. Now, the key thing, and you can see from the output on the command here, it says that the bridge priority must be in increments of 4096. The reason it's 4096 is for the system extension ID, or for the VLAN numbers, right? So we could have 0, we could have 4096, 96, we could have 8192, ... all the way up to 61,440, but it's going to have to be in increments of 4096. So how do we see what the priority is currently set to? Let me go ahead and back up, and this is where I'll make the window a little larger here. So if I do a do show spanning tree, right? And let me scroll back up a little bit. And again, remember that there is an instance of spanning tree for every VLAN. And this is the heading where it will start out with VLAN 1. And so let's talk about some of the values that we see here. So the first is the priority. Now, the default priority, right, by default, whoops, let me get this off here. So by default, the priority is 32.768, right? Now you're probably wondering, well, wait a second, it says 32.769 and you're telling me that the default is 32.768. So this is the root, whoever the root bridge is, and it is not this switch. We'll talk about that in a second. What happens is you have to take into account the system ID extension. And what does the system ID extension represent? It represents the VLAN number. And so again, the priority by default, right, you can see right here is 32.768. However, for each VLAN instance, the priority needs to factor in the VLAN number. So for VLAN 1, our priority will be 32.769, right? So spanning tree has been enabled, and the protocol is Rapid Spanning Tree Protocol, right? RSTP, Rapid Spanning Tree Protocol. And we'll come back to that because I believe it has us change it here. So who is the root bridge? So the ID of the root, his priority is 32.768 plus 1 for VLAN 1, which gives us 32.769. His MAC address is 0030.f20d.d6b1. The cost to get to the root bridge is 19, which means we're going to be going over a fast Ethernet interface. Here is the port out which I get to the root bridge. So if I'm on switch 1, we're on switch 1 here, and it says that the root bridge is out FA01, then there's a very good possibility that it's going to be switch 3, and we'll take a look at that here shortly. So this section gives us the information on the root bridge. The next section for VLAN 1 gives us the information about us, about switch 1. So this bridge ID, this is talking about the switch that we're on. So again, you can see his priority was 32.769, and most importantly, when we take a look at the MAC address here, you can see that 0050 is greater than 0030. So like we said, the priority can be from 0 to 61.440. The default is 32.768. So if you take the switches out of the box and deploy them, the default the default bridge priority is going to be equal on all of the switches. And if all of the switches have the same VLANs as ours do, then you have to go to the next criteria. So again, the second criteria is going to be the MAC address, right? And remember, in spanning tree, there's a common saying that lowest is best, or lowest always wins, and there is never a tie. So MAC address would be next. So you can see we have 0030 versus 0050. So this will explain why this bridge, or this switch, switch 1, this explains why he is not the root bridge, because you can clearly see for VLAN 1, he lost this election when all of the switches were sending BPDUs to each other, announcing themselves as the root bridge. Then they were inspecting the BPDU packets, the bridge protocol data unit packets, to see, well, this is my bridge ID is or my bridge priority is 32769, and this is my MAC address, and I'm receiving a superior BPDU from another switch on this port. So what will happen is switch 1 will then stop sending his BPDUs because he's receiving superior bridge protocol data units announcing from one of the other switches that my priority is higher than your priority. That's the first check. Or I should say lower. My priority is lower than your priority. And then the second check is, if our priorities are the same, let's look at our MAC addresses. And again, lower is always better, and there will never be a tie. So let's look at a little more of this output here as we scroll down a little bit. So what else do we see for VLAN 1? So we see the status of the ports, right? Or I should say the role and the state of the ports. So the port roles, remember that your port that is the closest to the root bridge will become a root port. So let me actually clear the screen here. So FA01 on switch 1, this is a root port. Because again, it's out this interface that he is closest to the root bridge. Take a look here. FA03 is a designated port, and FA03, and this is kind of tough to read, I'm assuming it's this guy here, and it's got to be because, again, he's not blocking. If he was blocking, he would be orange. So this guy is blocking, BLK. That's a terrible B. So BLK, and this guy is designated. And again, this is on switch 1. So designated ports will forward. Root ports are going to forward traffic. However, blocked ports will not forward traffic. And in the next video, we'll talk about the alternate port state. Excuse me, we'll talk about the alternate port state. Okay, so that was for VLAN 1. Let's clear the screen here and come back into the window. As you can see, remember we said that, again, you can see the root bridge is still the switch 0030, because if the default priority is the same for all of them at 32768, even when you add in the system ID extension for the VLANs, the priority values will be the same. So by default, out of the box, if you were to connect up a whole bunch of switches via trunk ports, the lowest MAC address is going to become the root bridge. So again, you can see we have entries for every single VLAN, right? And this is explaining to us the same information that we've previously seen. One key difference, if you notice, right? So for VLAN 40, what's the priority? 32808, because it's the default priority, which is set by default, plus the system ID extension. So if I were to say 32768 plus 40, we're going to get 80823. And that is how you come up with that priority number. Let's continue down here. And you can see we have an entry for every VLAN, including the management VLAN. So now let's transition over here to switch 3. Because just from looking at the diagram, what is it that you notice about switch 3, right? So switch 1 has, switch 1 has, and that is certainly not what I wanted to do. Let's go back here. I hit the wrong button. There we go. So let's get rid of that window there. Okay. And that is not, for some reason it's now transitioning back and forth here. All right, so we'll have to go it alone. So you can see here that these 4 ports are all green, indicating that these are all in the forwarding state. Switch 1 has a single port that is in the blocking state, and switch 2 actually has 3 ports that are in the blocking state. Excuse me. And My apologies, I had a phone call come in there real quick. So where did we leave off, right? So we're looking at the ports on switches 1, 3, and 2, and what we can see is you've got switch 3 has all of his ports are active and in the forwarding state. So let's jump on to switch 3, and let's go ahead and go from user exec to privilege exec and type show span. And so what do we see here for VLAN 1? So we've got some different output here than we had on switch 1. So for VLAN 1 it says this bridge is the root. And so that's the output that you should be looking for when trying to identify the root bridge, and you don't have this very convenient live status here where the ports are green, right, to see that every port is in the forwarding state, because that will be true of the root bridge, is that all ports will be in the forwarding state for whomever is the root bridge for that VLAN, right? And remember, it's per VLAN spanning tree plus. And what does the plus mean? The plus means that we're using 802.1q as our trunking encapsulation. If you look at some legacy documentation, right, and actually let me pull up, this would be a great time to pull up the Cisco website. And so if you were to do a search on Cisco per VLAN spanning tree and ISL, you may come along this page. And what it says here at the top is per VLAN spanning tree, or PVST, maintains a spanning tree instance for each VLAN configured in the network. It uses ISL trunking and allows a VLAN trunk to be forwarding for some VLANs while blocking for other VLANs. And so to take our conversation back to where we were the other day, let me go ahead and move this forward. And so we'll just talk about the per VLAN spanning tree versus the per VLAN spanning tree plus, right? And so I'll draw a little line down the middle here. So per VLAN spanning tree is only for ISL, or inter switch link, encapsulated trunks. Now, ISL is deprecated, right? So this is deprecated, which means it's no longer used. In fact, I believe on some of the later 15.x code, it is gone. It's not even an option to choose ISL as your trunking protocol, right? So contrast that with per VLAN spanning tree with the plus sign, right? This is only for 802.1q trunks, right? And this is also an open standard. And ISL, let me make sure we get this in. This was proprietary. I'm not going to be able to fit that in there. We'll go PROPR. So this was proprietary, right? Cisco proprietary, and only worked on Cisco switches. 802.1q is an open standard. It works on everybody's switches, right? And this is the default and what you should be running today, right? So if you're going to be running trunking protocol, right, you should be looking to do 802.1q. And so that is the difference between per VLAN spanning tree plus and per VLAN spanning tree. So, and again, let me go ahead and clarify or quantify this, that at the CCNA level, this is the difference. When you go to the CCIE level or the CCNP level, the difference between the trunking protocols and why it's PVST versus PVST plus becomes much more technical and much more in-depth as to why Cisco has these two different flavors. Now, let's remember that this all came about from the original 802.1d, right? And some people just refer to it as spanning tree protocol. You'll also see it referred to as the common spanning tree protocol, right? So, but again, the IEEE standardized the spanning tree protocol, And then Cisco took it and said, you know what, we're going to go ahead and we want it to be for every VLAN, because again, the original spanning tree protocol was for one VLAN and so your entire topology, right, was controlled by spanning tree, but it was all one massive spanning tree domain. So Cisco said, you know what, we've got this cool technology where we're doing VLANs, so we're going to take it, we're going to add our secret sauce, and we're going to use it with ISL. We're going to call it PVST, right? 802.1q trunking came along, and Cisco said, that's okay, we're going to take the standard, and we're going to go ahead and add our secret sauce, and it's just going to be PVST plus. So if you see in legacy documentation, you may run into it in other locations where you see PVST, know that PVST is Cisco's proprietary spanning tree mode, right? And so think of it like this. So the mode is per VLAN spanning tree, and the mode is per VLAN spanning tree plus. The protocol is the spanning tree protocol, and it's the same on both sides, right? Protocol, which you will hear sometimes referred to as the common spanning tree, right? But most people will say it's just spanning tree protocol. And again, this was IEEE, right? 802.1d. Oops, forgot the I, the IEEE, right? And so think of it like this. It's not that this is like this brand new protocol, right? It's easier to think of it as the protocol, it's spanning tree protocol, the IEEE standard, and Cisco's mode, and what they did with it is they called it PVST. And again, the PVST is for ISL. Same thing here. For 802.1q, it's just PVST plus, right? Little extra added secret sauce. And again, it's leveraging the same standardized protocol, but Cisco, like they do with many things, took the standardized protocol and customized it for their hardware. So again, you can see here that since PVST treats each VLAN as a separate network, it's got the ability to load balance traffic at layer 2 by forwarding some VLANs on one trunk and other VLANs on another trunk without causing a spanning tree loop. And that's really what we're here to do when we move on with this video. And if I click on per VLAN spanning tree plus, what does it say? So again, PVST plus provides the same functionality as PVST. However, it's using 802.1q trunking technology rather than ISL. And so this is an enhancement to the 802.1q specification, right? So again, this, for new learners, this is typically one of the most confusing things. Is you hear about spanning tree, you hear about common spanning tree, you hear about PVST, you hear about PVST plus, RSTP, and then you hear about RPVST plus, and it can become a little confusing. So hopefully this is going to clarify that for you. So let's go ahead and iconify this. And this is where, again, RSTP is Rapid Spanning Tree Protocol, but that is not, it's not representing PVST or PVST plus. We'll talk about that in a second. So let's step back here and continue on. You can see the root bridge, all of the root bridge ports are designated ports, because all of the root bridge ports in our scenario here, because we haven't changed anything with respect to priorities for VLANs, all of the ports are going to be forwarding ports on the root bridge. All right, so back over here, because there's a separate instance of spanning tree for every active VLAN, a separate root election is conducted for each instance, right? And right now, all of our instances here, you can see, all things being equal, we are the root bridge. This bridge is root, this bridge is root, this bridge is root. So we are, switch 3, the root for all VLANs. Now, that's a lot of output there. If I were to say show spanning tree root, show spanning tree, and is that not an option here? Aha, it is not an option. So I can do summary, that's not what I want. So I'm going to go over to a real Cisco switch here, and this is a 3750, and I'm going to go ahead and say show spanning tree root. And this is a much quicker and much easier way to get some really nice output that's very quick and easy to read. So let's take a look at this. For VLAN 1, I can already tell you that I am not the root bridge, and the reason, all I have to do is look here and see there's a cost to get to the root, and I get to the root out this port. So this clearly, for VLAN 1, clearly describes another switch is the root bridge. But let's take a look at VLAN 2. For VLAN 2, right, my cost is 0. And if my cost is 0, and we've got 24,578 here, and I don't have to go out a port to get to the root bridge, what does that mean? Let's take a look. If I do a show spanning tree on VLAN 2, who is the bridge? This bridge, or who is the root, I should say. Who is the root? This bridge, and again, bridge and switch are synonymous in our conversation here. This bridge is the root bridge, right? So for VLAN 2, and so then we know that if you have a cost of 0 and there's no port listed, you're not going out a port because the cost is 0, you are the root bridge. So if I ran this command again and said, what about VLAN 18? This bridge is the root. What about VLAN, I believe it was 19 that was next. This bridge is the root. And the other common quality that you're going to see is all of our ports, and I think if I hold down Control, no, it's not going to let me do it. Is it Option? Yeah, I just want to get the column there. So all of our ports for ports 19, 20, and 21, they are all designated ports. They're also, the role is designated. The state is in the forwarding state, right? So you can clearly see that we are the root bridge. All right. So unfortunately, we didn't have access to the show spanning tree root command there, but that's okay. All right. So let's come back over here. The root switch is responsible for generating the BPDUs for a spanning tree protocol 802.1d. Remember, that's the standard, right? And it's the focal point for spanning tree to control traffic. So the root switch must be capable of handling this additional load. It talks about the placement being key. And let's jump in here. So spanning tree mode, we're going to configure the switches so that they use PVST as the spanning tree mode. So we're going to go into global config, and I'm going to type in spanning tree mode, and here are my two choices: per VLAN spanning tree or rapid per VLAN spanning tree. So I'm going to say PVST. Now remember, before it said RPV or RSTP as the mode, right? Or I'm sorry, as the protocol. So we'll change the mode. So spanning tree mode per VLAN spanning tree. So now when I do show spanning tree, it no longer says RSTP, it says IEEE. And the reason it says IEEE here and not STP, it goes back to when Radia Perlman, and I believe it was 85, where Radia Perlman actually invented the spanning tree protocol while working at Digital Equipment Corporation, DEC. And they submitted, DEC submitted to the IEEE the spanning tree protocol as a proposed standard. So they couldn't put DEC on it as the standard. So the IEEE also made some minor changes to it, and that's why it says IEEE here. It simply represents the fact that this is the spanning tree protocol 802.1d IEEE, and this is the legacy spanning tree protocol, right? And so again, it can be very confusing to say, okay, well, I just ran a command that said spanning tree mode PVST. Why is it telling me that the protocol is IEEE? And again, it's that separation of the Cisco mode, right? Spanning tree mode is using the IEEE spanning tree protocol. Because again, right, it was ratified as 802.1d, spanning tree protocol, STP. Cisco took that, enhanced it, added their secret sauce. For ISL trunks, it's PVST. If you're using 802.1q trunks, it's PVST plus, right? But again, the protocol, it's the same protocol. It's just that Cisco tweaked it, and they say, oh, let's change, we'll refer to it as the mode. However, in the output here, it still says IEEE, right? Okay. So I'm going to take a short break here. I'm going to get something to drink, so please stand by. All right, so let's pick up where we left off. We're going to go ahead now and change the mode on switch 2. Go from user exec into privilege exec and then into global config with that same command, spanning tree mode. And what are the mode choices? PVST. We want per VLAN spanning tree because that is using the STP spanning tree protocol that is identified by the standard 802.1d. Right? So we just changed the mode on switch 2. Let's change it on switch 1. So from user exec to privilege exec into global config, spanning tree mode PVST. Okay. So now we're going to get into some load balancing. So this is what I like to call layer 2 traffic engineering. And one of the important things to remember here is that when we set the root bridge, right, it's not like we have control over it, such as a routing protocol where I could tweak sort of certain cost by setting the root bridge to be one switch or another. Look at it as the root bridge, right? The root bridge is a reference point for all other switches in the environment to set their ports to be either forwarding or blocking. Because remember, it's a reference point because the root bridge for the VLAN in question, that port's going to be in the forwarding state, right? So we want to load balance because we want to take advantage of all of these links. Because if these were not fast Ethernet links, let's say these are 10 gig or 40 gig links, I don't want this link to be in a blocking state if it doesn't have to be. And the same thing here. If you take a look at switch 2, switch 2 has 3 of its 4 links are blocked. So that could become a very expensive proposition if you had to explain to your manager, unfortunately, I've got to block, these 3 links come up as being blocked. So switch 2, even though it has 4 10 gig links, is only going to be using one of those at a time. So that leads us into the load balancing conversation. So it says configure switch 1 to be the primary root VLAN, or the primary root for VLANs 1, 10, 30, 50, 70. So let's jump on to switch 1 here. And it's going to be interesting to see how they want us to do this, because there are 2 ways that we can do this. The first is using a macro, right, which would be spanning tree. I'm going to say VLAN 1. And the macro would be if I typed in, the macro would be if I typed in root and then primary, right? So what that command is actually doing is it's running the command spanning tree VLAN 1 priority 24576. I believe it's 24576, and we can check that. So I'm going to actually run this command right now, and we've got 72 points. Let's see if we get awarded any additional points here, if that was the command that they were looking for. And it doesn't look like it was, but let's check here. So if I do a do show span now, you can see, and we did that for, was it just VLAN 1, the first VLAN that we did? We did, and so here it is for VLAN 1. You can see that 24576, exactly. So that's referred to as a macro, right? And you can think of a macro as sort of like an alias where we run the command where we say root primary, but what is really happening behind the curtain is that the Cisco switch is running the command spanning tree VLAN 1 priority 24576. So this macro will drop the priority to 24576 for us. However, if somebody were to configure a switch and put the priority at 0 or put the priority at 4096, anything below 24576, and introduce that switch into the environment, there's a very good possibility that you will lose your root bridge status on that switch for the VLANs in question. So I'm going to run that same command. Let's run that on switch 3 as well. And now, what else did we notice here, right? And this is one of the nice things about PacketTracer, is that we've got this live status on our ports. We've now got all of our ports in the forwarding state. However, it's important to point out that not all of those ports are in the forwarding state for every VLAN. So they're in the forwarding state on switch 1 right now only for VLAN 1, and if I were to do show span, because we're the root bridge for VLAN 1, so what does that mean for us? That means that all of our ports are designated, therefore they're all forwarding, right? Now that's VLAN 1. What does it say for VLAN, or was that VLAN 10? I apologize. Yeah, that was for VLAN 10. How about VLAN 1, right? So it still shows here that it's root and it's got some designated and some blocking. But for VLAN 10, everything that we're doing in terms of the spanning tree priority, we're designated and all the traffic or all the ports are in the forwarding state for that VLAN because this bridge is the root. Let's take a look at VLAN 20. It says that this bridge is the root, and we're going to be changing that. VLAN 30, we are not, right? So the interfaces are all in the forwarding state. So we need to take a look here and see why it's pushed everything into the forwarding state except the VLAN we changed the priority on. Or actually, I apologize. I didn't realize. I'm on switch 3. I thought I was still on switch 1. I apologize. So let me go back to switch 1. I'm very sorry about that. So on switch 1, do show spanning tree. It was very odd output, and then I realized that I was not on switch 1. So when I'm on switch 1, because we are the root bridge, all of our ports are in the forwarding state. For VLAN 10, and this is what I was anticipating because we haven't run the command yet, you can see for VLAN 10 we've got a blocking port, a designated port, and then we have a root port indicating that we are not the root bridge because that's the port we have to go out to get to the root bridge. So let's go ahead and run that command for VLAN 10, 30, and 50. And I apologize. Again, I did not realize I had switched over to switch 3 and then saw things that were not anticipated on switch 3, thinking I was on switch 1. All right, so we have changed the root bridge, and we are getting the points, so it looks like it was expecting the macro, but I'll run the other option to set it as the root bridge. We'll do that on switch 3 and see if we're also awarded the points. So if I do a do show spanning tree now, you can see for VLAN 10, now we're the root. All of the ports, the role is designated, and the state is forwarding. VLAN 20, we are not. As you can see, on VLAN 20, FAO2, right, shows up as the alternate blocking state for this VLAN. But the little link light here, right, the reason it's green is because for VLANs 1, 10, 30, 50, 70, all of these ports are active. And so this is where it's kind of tricky, right? Because if you look at this, well, all of these links are green and all of these links are green. Well, that means that they're all forwarding. They are, but you got to come in and look here at the do show spanning tree to see for which VLANs are those ports forwarding, right? That's the key. That's the per VLAN spanning tree. So VLAN 30 were the root bridge, for 40 we're not. For 50 there, right above the VLAN 60, we are. If I come down, you can see for 60 we're not, right? We've got blocking ports. So that was switch 1. Now let's go ahead and jump onto switch 3 here. And I'm going to run this command in the alternate form. So I'm going to say spanning tree mode, and I shouldn't say mode, I apologize. Spanning tree VLAN 20 is going to be our first VLAN, and we're going to say priority 4096. And that is definitely going to make that switch the root bridge for VLAN 20. Let me do 40. Let's see if we get any points here. 78 points, so keep an eye on that. 60 and 80 and 99. So we had 78 points. It looks like we still have 78 points. It might be that it did not want that command. Let's see if it wants the macro. So I'll come back here. We'll turn this off. We'll say no. Spanning tree 20. No 40. Basically setting it back to its default for each of these VLANs of 32,768. And then let's go ahead and we'll say, but again, I wanted to make sure that you saw the alternative if you wanted to drop the priority to make extra sure, and this is actually a recommended best practice, is to hard code the entries with that lowest value possible. So on the switch you want to have you want it to be your primary, you could set it to 0. On your secondary you would set it to 4096 in case the primary failed. And that way it's also deterministic, because you want to make sure, especially when you're dealing with spanning tree, that if your environment, if your root bridge goes down, that you know exactly how that the spanning tree domain is going to reconverge. All right, so here we go. Spanning tree VLAN 20. And I apologize there, priority, we want root, and we're going to say primary, right? Because we're going to make that the primary. So we'll say VLAN 40 primary, VLAN 60 primary, and VLAN 80 primary. And then also let's get VLAN 99. All right. So we've got all of the primaries on switch 3 set for VLAN 20, 40, 60, 80, and 99. And then, as you can see here, what's our last step? Configure switch 2 to be the secondary for everybody. So if I come on to switch 2, this is going to be easy. So we're going to say, we'll go from user exec to privilege exec into global config. And I'm going to say spanning tree VLAN. And okay, good. We can do a range here. So I'm going to say 1, 10, 20, 30, 40, 50, 60, whoops, 70, 80, and 99, followed by root. And are we going to be the primary? No, it wants us to be the secondary. And so let's watch and see what happens here on switch 2. You can see that switch 2 now has 2 of its 4 links blocking, and blocking for specific VLANs. And if I do a do show spanning tree now, what happened to the priority here? So this is the built-in value that will be used when you use the macro to set the secondary, right? Because remember, the secondary value is going to be higher than the primary value. And so the 2458, the 24567 or 576 will get, says 576, will get bumped up by 4096, and the secondary priority will be 28672. And so let's see, is that consistent here? 28672, 28672, because again, what's the root priority on all of the VLANs? Right now it's 24576. So root or switch 2, since we set it as a secondary for every single VLAN. And take a look there. As you can see, all of our ports are now in the forwarding state. Some of this may change. You can see we still have some in the listening state. Let me run the command again. So some of them are still in the listening state, but they should have transitioned now out of that. And you can see that we're actually using all of the links, but not all of the links are being used for every single VLAN, right? Because again, we're sharing the load. And this is what we refer to as sort of layer 2 traffic engineering. All right, so verify my configuration. We did. And so the last couple commands, it says configure port fast on the switches. Port fast causes a port to enter the forwarding state almost immediately. And that is certainly one important reason to turn port fast on. Let's make sure that it wants minimizes it. So configure port fast on the switch interfaces that are connected to the PCs. So we're going to go into interface FA018, and I'm going to say spanning tree port fast, and I'm going to hit enter. And you'll always receive this, right? You definitely want to be very careful turning port fast on. You never want to set port, I shouldn't say never. You want to make sure you're very selective about turning port fast on because you can turn it on for trunk ports as well. You want to make sure you're very careful about doing that when you're connecting another switch, right? Because you could end up in a situation where you introduce a spanning tree loop. So we've got port fast on switch 2. Let's turn it on switch 1 for interface FA06. We simply say spanning tree port fast. And then on switch 3, we're going to go in interface FA011, and I'm going to say spanning tree port fast. All right, so that takes care of that. So our final step is going to be configure BPDU guard, right? Now, if you turn port fast on a port, the recommendation would be, if it's on an access port, like we've configured for the PCs, that you always configure BPDU guard. And here is why. If someone came into your environment and unplugged the PC and plugged in a switch, that switch is going to start to send BPDUs. And remember, when switches start to see superior BPDUs, it is a preemptive process, right? So right now, and we just saw that. So right now, the root bridge for switch 3, and let me come over here so I can draw this, right? So our root bridge, we've got switch 3, and that was, in fact, let's back that up. That was not what we're looking for. So we'll say this is switch 3. We've got switch 1 and switch 2, right? And we've got these multiple links running between the switches, right? But we've got a PC here, and we've got a PC here. So if somebody unplugged that PC and they brought in switch 4, and they plugged it into that PC port right there, and that port's up, or let's say any other port on here, right? Because on a lot of the switches, the trunk ports are it's set up to trunk by default, right? So if these guys negotiated over a trunk port, and the priority on this switch is 0 for all VLANs, guess what? The fact that this guy was the root bridge for the evens, and that this guy is the root bridge for the odds, and we set it to 24576, or maybe you've got another value in here, this guy just became the root bridge for everybody, right? And so by turning on BPDU guard on the interface, if the interface receives a BPDU, it immediately puts the interface into an air disable state, and it is down. Right? It'll shut that port down, which is, in a controlled environment, that's what you want. The other alternative is, let's say you've got some VMware or an ESXi server, right? Or ESX server, and he's plugged in, and they've got like their little internal switch in here, and I've seen this happen with IBM VIO servers, and they try to do like a dual connection or a dual heartbeat connection off of like a VIO server. You could end up with a spanning tree loop, right? If you do not have BPDU guard enabled, if it's misconfigured, I should say, on the server side, because you've got a loop right there and it can take down the entire environment. And I've actually, unfortunately, had to experience this being done and that happening. So that's what BPDU guard is for, right? So on host-facing ports, right? So let's change my color here. On host-facing ports, I want to make sure that that port has port fast and BPDU guard to guard against BPDUs showing up on this port, because if there is not a switch connected here and it's supposed to be a host, no host should be sending you BPDUs, right? Trying to preemptively take over as the root bridge. That is not the job of a PC, a server, or your ESXi boxes, right? So beware of that. Okay, so let's go ahead and knock this out. It's asking for BPDU guard on switch interfaces that are connected to the PCs. So again, I'm going to say spanning tree, and we're going to have a BPDU guard, and there should be an enable, right? So we'll turn that on switch 3's host port. We'll do it, whoops. We're going to do it on switch 1, so spanning tree, BPDU guard, enable, and then let's come over here to switch 2, spanning tree, BPDU guard, enable, and that should be it. So we're at 95, and it looks like I may have skipped a step. So let's check our results. Take a look at the active items checklist, and we've got green checks all the way down, with the exception rapid spanning tree protocol. So our STP for VLANs 20, 40, 60, and 80. Maybe I misread the instructions here. Let's take a look. And 20, 40, 60, and 80. So it wanted us to enable PVST plus. Configure the STP mode. So we did that. Use the spanning tree mode to configure the switches so that they use PVST as the spanning tree protocol, or as a spanning tree mode. So we configured the load balancing, and we have verified all our configurations. So did I not change the mode on spanning tree mode PVST? Did I not get that on all of the switches? It says VLANs 20, 40, and 60. So spanning tree mode PVST. And let's see. Do show span. So if it's PVST, we should see the IEEE. We should see the IEEE, and do show span, we should see the IEEE. And so that's interesting that it's asking for the rapid spanning tree protocol on 20, 40, and 60. Let me change it for VLANs, for the VLANs where this is the root, spanning tree mode, and we're going to say rapid PVST, and let's see if that actually, and that actually dropped points, so that is not what it's looking for. So we're going to go ahead and change this back to per VLAN spanning tree. And maybe I'm not reading this right. Let me take another look at this here. So let's see. Spanning tree protocol, rapid spanning tree protocol, correct. So it's not, we're not running our STP, but the priority is incorrect. So let's go ahead and check to see. And so now we've got to wait here while spanning tree reconverges on switch 3. Let me check to see. Do show spanning tree here, and for VLAN 1 it should not be the root. Okay, there we go. The ports are back up, so let's run it again. So for VLAN 1 it should not be the root. For 20, the bridge is the root, and the secondary bridge should be VLAN, or secondary bridge should be switch 2. And so let's see here, priority 0. Why is it saying priority 0 on switch 3 for VLAN 20? Did it not remove those commands I ran earlier? So spanning tree VLAN, aha. So looks like we had an order of operations issue here. So I'm going to have to issue the no spanning tree. When I used the command earlier to hard code the priority, it looks like it dumped them all in there together, and so when I was running the command to remove each one, it did not take. So let's say do show run. All right, so now let's go ahead and say, and command's probably way back. Yeah, it doesn't even go that far back. So we're going to say spanning tree VLAN, and we can do 20, 40, oops, keep it together, 20, 40, 60, 80, 99. Is that correct? Let me make sure that that's supposed to be our secondary. Or, I'm sorry, the primary. 20, 40, 60, 80, 99. And again, when I ran the command initially, I had used priority 0, but that's not what they're looking for here. They want you to use the macro. So I'm going to say root primary. And let's see if that gets us those last 5 points and sorts out the challenge that we had earlier. So now I'm going to do a do show run. All right, and so it looks like I may have had the VLAN 99. Shows the priority is 24576, and it's setting the priority to 0. So let me do this. I am going to go ahead and we're going to reload. Whoops. We're going to reload the switch. I haven't saved my config, right? So let's say reload. I'm going to confirm with the reload. So it should wipe the configuration off of switch 3. As you can see, we've got quite a few red lights, and we are going to whip through the configuration on switch 3. So let's go back and take a look. So what are we going to do right out of the gate? And I'm going to do this rather quickly here. So we're going to create the VLAN. So we're going to say VLAN 10, VLAN 20, VLAN 30, whoops, VLAN 30, VLAN 40, VLAN 50, VLAN 60, VLAN, oh, not 600, no VLAN 600, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. And this is always good because it gives you a chance to troubleshoot, to take a look at things here. So we've got our VLANs created. We need to go ahead and go into int FA011. We know that this is going to be switch port mode access. We know it's going to be switch port access VLAN. Which VLAN was this on switch 3? VLAN 10. So I'm going to keep us there. So VLAN 10. We know we're going to put port fast on, not port security. Let me back that up there. No switch port. So spanning tree, we're going to put port fast on, and we also know we're going to do BPDU guard, enable, do show run. Let's check our port there, 11. So that looks good, except for, we'll bring it up. So we'll say no shut. Okay, so that took care of the port setup. Verify the VLANs, do show VLAN brief. And we're good. 10, 20, 30, 40, 50, 60, 70, 80, 99. Okay. And we're going to go ahead and configure interface range FA01 to 4. We're going to say switch port mode trunk. We're going to say, looks like they're all up. And we're going to say switch port trunk native VLAN 99 to get rid of that native VLAN mismatch. And that should have taken care of that. We're also going to come back out of here and say spanning tree mode PVST, because we know we need to be at PVST. And so now we should be to the point where we've got 93 points, and this should do it. So let's go ahead and say spanning tree. And again, VLANs, and for switch 3, it's going to be the primary route for 20, 40, 60, 80, and 99. And we're going to say root primary. And so we've definitely got a few more points there. And let's go ahead and see. It's going to reconverge. Let me check results real quick, because I'm obviously maybe missed one thing there in the rush. And hopefully it's not going to be these port priors. Ah, right. Excellent. So configure the VLANs. Okay. Or configure the management VLAN, which is going to be VLAN 99 on switch 3. So I'm going to come in here and say interface VLAN 99. And we're going to say IP address on switch 3 is 172.31.99.3/24. And we already did the no shut. And that is going to take us to 100 out of 100. All right, so I apologize there at the end for having to, and again, with PacketTracer, sometimes you'll run into issues like that where if you issue the wrong command, it's expecting the macro. Again, it's not the full-blown iOS. And so typically what I do is I'll simply reload the PacketTracer switch or router that I'm on and then start from scratch. And as you can see, that clearly rectified the problem that we were having on switch 3, and we've now been able to complete this activity. All right, so this concludes PacketTracer activity 2.3.1.5. You should definitely have a much better understanding of not only sort of the history of spanning tree and how we came to talk about PVST and PVST plus. Keeping in mind, remembering that those are the modes. So Cisco took the spanning tree protocol, the standardized protocol, added their secret sauce for ISL, and called it per VLAN spanning tree. Then 802.1q became a standard form of doing trunking, and so then Cisco said, well, then we'll just say it's PVST plus. And the next video, we're going to talk about our PVST plus, which is the rapid spanning tree protocol, and we're going to have that same conversation. All right. Thank you for watching, and I will see you guys on Saturday morning.